think about how much scientific research gets published. It's a
Yeah.
constant flood, right?
Absolutely overwhelming sometimes.
Now imagine you're one of the experts uh, tasked with reviewing it,
Yeah.
making sure it's sound before it becomes part of, well, our understanding of the world.
Yeah, the gatekeepers, essentially.
How do you even begin to keep up? To really dig into each paper and know how it connects to everything else that's already out there,
Yeah.
it feels like you'd just be drowning.
Drowning is a good word for it.
But what if there was a way, maybe using technology, to step in and help you quickly grasp what's important and maybe see those crucial connections faster?
Well, that's exactly the problem this new tool we're looking at aims to solve, making that initial deep dive into a scientific manuscript much more efficient for reviewers.
And that's what we're exploring today on the deep dive. We've got the details on a fascinating piece of tech, a Python script called the Reviewer Assistant Agent, or RA for short.
RAA.
Now, even if you're not, directly involved in scientific peer review, this is still really interesting. Because think about it.
Hmm.
This tool is all about quickly processing and comparing complex information.
Mm-hmm.
And that's a skill that's valuable in just about any field if you want to stay informed, wouldn't you say?
Absolutely. I mean, by understanding how this RAA thing works, you get a real sense of how AI can move beyond just, say, summarizing text.
Right.
And start actively identifying key bits of information and, crucially, drawing comparisons. It gives you a peek into the future of how we might all handle this information overload problem.
Okay, so our goal today then is to really understand this RAA, what it is, how it actually does what it does, and what kind of information it manages to pull out of these dense scientific papers.
And, crucially, how it compares that info.
Exactly. How it goes about comparing that information to other research that's already out there online. Okay, so let's dive in. What exactly is this reviewer assistant agent?
Okay, so in simple terms, the RAA is a computer program. It's written in Python, and it uses a pretty powerful framework called LangChain. You might have heard of it.
LangChain, yeah, it helps build AI apps, right?
Exactly. It makes it easier to build applications that use large language models. In this case, it's using an advanced one from OpenAI, probably something like GPT 4.1 mini.
Okay.
Its main job is to take scientific manuscripts, specifically PDFs, and not just read them, but analyze them in detail.
Analyze, not just read. Got it.
Then, and this is key, it goes online to find other relevant scientific papers and compares them back to the original manuscript.
So it's not just looking at one study in isolation. It's actively trying to place it within the bigger picture of what we already know. That sounds huge for efficiency.
It's a big step, yeah. And you mentioned LangChain, that's really orchestrating the whole thing.
Is that how it works?
Pretty much. Think of the entire process, like from the moment the manuscript gets loaded to when the results pop out, as being managed by something called a LangChain AgentExecutor.
AgentExecutor. Okay.
Imagine it like a smart conductor leading an orchestra. But the orchestra is made up of specialized tools, each designed to do one very specific job in the analysis.
Okay. Okay. So it's like having this super focused research assistant built right into the software. Now, if I'm a reviewer using this RAA, what's the main thing it's supposed to help me achieve? Like, what's the goal for me?
The main goal is really to make those initial stages of review much faster and hopefully more insightful.
Okay.
So firstly, it aims to give you a quick handle on the main findings. It does this by generating concise summaries.
A quick summary, always useful.
Definitely. Secondly, it's designed to automatically pull out very specific quantitative data points from the manuscript. Numbers.
The hard data.
Exactly. In this particular case, the example focuses on things like the percentage of corrosion inhibition,
Okay.
the impedance, which is measured in ohm centimeters squared, and the adhesion strength measured in megapascals, or MPas.
Yeah. So really targeted numerical information. That makes a lot of sense if you want to objectively compare different studies in these fields, doesn't it?
Precisely. You need those numbers side by side.
And once it has that data from the paper being reviewed, what happens next? Does it stop there?
Oh, no, it doesn't stop there. The crucial next step is to find relevant existing research.
Okay, how does it do that?
The RAA does this by running web searches. It uses the title of the manuscript it's analyzing as the search query.
Makes sense.
And what's really helpful is that once it finds these potentially relevant articles online, it tries to do the exact same thing it did with the original paper.
Which is?
Extract those same key quantitative metrics, the corrosion, impedance, and adhesion numbers, so that you can make a direct side-by-side comparison.
Wow, okay. So it's building its own little database of comparable data points almost on the fly.
Kinda, yeah. for that specific review task.
If you're trying to understand how new research fits in.
Yeah.
Yeah, I can see how valuable that kind of automated comparison would be. Let's get into the specifics, the nitty-gritty of how this RAA actually works. Can you walk us through the step-by-step?
Sure thing. So the whole process kind of kicks off with initialization.
Right.
This is basically where the script takes care of all the behind-the-scenes setup stuff, like making sure it has the necessary API key to talk to the OpenAI model and reading in any specific settings you might have configured. Getting its ducks in a row, basically.
Okay, standard setup. What's the first real step in actually analyzing a manuscript?
Right. The first thing it needs is the content of the manuscript itself. This happens in the load manuscript step.
Okay.
It uses a special tool called load manuscript tool. And under the hood, that tool uses a component called PyPD floater.
Ah, PyPD floater. I've heard of that.
Yeah.
For reading PDFs in Python.
Exactly. This essentially reads and pulls out all the text from the PDF file you give it. And importantly, it also keeps track of information about the different pages in the document. That becomes useful later.
So it's not just grabbing the words, it's also understanding the structure, kind of page by page.
Sort of, yeah. It
Yeah.
knows which text belongs to which page.
Then I guess it needs to know what paper it's actually looking at, the title.
Exactly right. The identify title step is where it tries to figure that out. It primarily looks for the title within the text of the paper itself. Usually it's right there at the beginning. But it's also smart enough to have a backup. If it can't, for some reason, find a clear title within the content,
Yeah.
it'll just use the file name of the PDF instead.
Ah, clever. Good to have that safety net. So now it has the text, page by page, and hopefully the title. What's the next task it tackles?
Okay, once the manuscript is loaded and it knows the title, the RAA moves on to summarize manuscript.
The summary we talked about earlier.
Yep. It uses another custom tool here, the summarize manuscript tool. This tool leverages a function called load summarize chain.
Okay.
And this basically takes the page data that was loaded earlier and generates a nice, concise summary of the entire manuscript. For you, the reviewer, this gives that high-level overview right away. Quick understanding.
And the source we looked at gave an example, didn't it? Something like, this paper shows that this specific inhibitor achieved 92% effectiveness. Something
Shoots out,
like
but it boils down the core finding into a really easy-to-understand statement. Like, here's the main punchline.
That's super helpful for getting oriented fast.
Totally. So following that summary, the agent gets down to extracting those specific numbers we talked about. This is the extract manuscript metrics step.
Okay, finding the actual data points.
Right. It uses the extract metrics tool, which talks to the language model. It essentially asks the model, hey, scan the full text of this manuscript and specifically look for the values for corrosion and emission as a percentage, impedance in ohm.cm maffin, and adhesion in MPA.
So it gives it very specific instructions.
Very specific to make sure it's looking for exactly the right info in the right units.
And again, the example output really showed how targeted this is. It pulls out things like 92% corrosion inhibition and that specific impedance value, 2 by 108 ohmmane.cm IV.
Yep.
So it's not just summarizing in general terms, it's really pinpointing that hard data. What happens once it has this information from the manuscript itself? Where does it go next?
Okay, now comes the part where it starts making connections to the outside world. The search similar articles step is next.
Right, looking for related work.
Exactly. Using the title it identified earlier, the RAA uses the search similar articles tool. This tool uses the DuckDuckGo search library.
Oh, DuckDuckGo. Interesting choice.
Yeah, to go out and find URLs of articles online that are likely to be related to the manuscript it's analyzing.
How many does it look for?
Well, the number of search results is actually something you can configure. The default might be 10, but the example we have shows it was set to look at 20 results.
So it's casting a fairly wide net then, trying to find relevant existing work.
Seems so.
And we saw from the examples the kinds of places it finds big scientific publishers like Springer, Science Direct.
Nature.com, Semantic Scholar.
Yeah, that seems like a good range of scholarly sources.
Yeah.
So what does it then do with all those website addresses? Just give you a list.
No, it goes further. This is where the process similar articles step comes in. It takes that list of URLs,
Okay.
and for each one, the process web article tool gets to work.
What does that tool do?
Well, it tries a few things. Its first attempt is usually to directly download a PDF file from that URL. Lots of scientific articles are available as PDFs, right?
Right, ideally.
If it can't find a PDF directly, or maybe if the page is just HTML, like a regular web page abstract,
Yeah.
it'll then try to parse that HTML, look for any links to PDF files on that page, and try to download those.
So it digs a bit deeper.
And as a last resort, if there's really no PDF to be found, it will even attempt to extract the main text content directly from the HTML of the web page itself.
Wow, okay. It sounds like it has to be really flexible then to deal with all the different ways scientific info is presented online.
Absolutely. It's not always straightforward.
So the key thing here is getting the text from these online sources, one way or another.
That's the goal. And once it has successfully managed to get text from one of these online sources, whether it's from a downloaded PDF or scraped from a web page, it then uses that exact same extract metrics tool we talked about before.
The one that found the numbers in the original manuscript.
That's the one. It uses it to try and find those crucial corrosion, impedance, and adhesion metrics within this external article's text as well.
Okay. So it's trying to build that parallel set of data points from the existing literature for direct comparison. That's really the core of the comparison part, isn't it?
That's the core idea, yes.
Now, the source mentioned different processing statuses for these online articles. What kind of feedback does it give? Like, how well is this working?
It gives really useful feedback, actually. It reports on how it fared with each website it tried. So, for example, you might see a status like HTML scan failed, meaning it probably had trouble even identifying the main content block or finding any PDF links on that web page.
Okay.
Or you might see direct download failed if it couldn't grab a PDF straight from the URL it was given.
Right. And on the successful side,
You'd see something like PDF downloaded and text loaded, which is great, means it got the text.
good.
And then crucially, after loading the text, it reports whether it actually found those key metrics. So you'll see if the corrosion value was found or if impedance was not found, for instance.
And looking at the sample results you shared, it seems like,
Yeah.
well, it doesn't always manage to extract those specific metrics from the online articles, does
Yeah.
it? Even when it successfully loads the text.
That's a really key observation. You're right.
Why is that, do you think?
Well, it probably tells you something about how consistently this kind of quantitative data is reported across different scientific papers, different journals, different authors.
So the data might just not be there in the same format, or maybe not there at all.
Exactly. Even with a sophisticated language model doing the searching, consistently pinpointing very specific data points across a wide variety of documents, all with different structures, different phrasing, different formatting, that's a real challenge.
Yeah, I can imagine.
You see examples in the output where, one PDF yielded a nice, clean 99.75% corrosion inhibition. Easy.
Right.
But then another article might use more descriptive language, like the example, 3 orders of magnitude higher than EP after 35 days for impedance.
Which isn't a direct number it can compare easily.
Exactly. And the tool correctly identifies that as essentially not found in the format it needs. So this really highlights for you that while AI is incredibly helpful, it's not. It's not a perfect solution yet.
It's not magic.
Right. And the way information is presented out there in the real world can be quite messy, quite inconsistent.
That makes sense. It's looking for very specific units and formats. And if they're not there, tough luck for the automation. So, okay, after all this searching, loading, processing, trying to extract data, what happens with all the information it has managed to gather?
Right. The compile and output results step is where everything comes together.
Yes.
All the info, the original manuscript's title, its summary, the specific data extracted from it, and then that detailed list of all the similar articles it processed, along with their processing status for each one, and any metrics it managed to pull out of them. It's all organized neatly into a single JSON object.
JSON. Okay. So a structured data format.
Exactly. The source showed a really clear structure for this, with like a main section for manuscript analysis and another big section for similar articles analysis.
So it's a structured way for maybe another program or just the reviewer to access all of his findings.
Yeah.
And how does a reviewer actually see all this information? Is it just the JSON?
No, it makes it more user-friendly than that. The display and save step takes that structured JSON output and presents it in a way that's, easy for a human to understand.
Oh.
The script prints all this information directly to the computer screen in a well-organized format. Crucially, this includes a clear table. It uses a library called Pandas, which is great for data tables.
Oh, yeah. Pandas is standard for data analysis.
Right. So it makes this table showing The list of similar articles, their website addresses, the status of how they were processed, downloaded, failed, etc., and then the extracted metrics all laid out nicely in columns.
Ah, that table sounds really useful for quick comparison.
It really is. And it also gives you the option to save all that data about the similar articles at the table basically into a separate CSV file.
CSV, comma, separated values.
Yep. Which
Yeah.
could be really useful if you wanted to do some more detailed analysis later, maybe pull it into a spreadsheet or something.
Okay, so let me recap. The reviewer gets a quick summary of the paper they're looking at. The key numbers, like corrosion or adhesion, pulled right out for them.
Yep.
And then this list of related research it found online, with an attempt to pull out those same key numbers for a direct comparison, all presented clearly, especially in that table.
That's the essence of it, yeah.
That sounds like it could save a huge amount of time, especially in those initial stages of review, just getting your bearings.
It really automates those first, often very time-consuming tasks, getting to grips with a new piece of research and seeing sort of where it fits in the existing landscape.
Okay, so for our listeners, people who are maybe interested in just gaining knowledge quickly but also thoroughly, what are the key things to take away from understanding how this RAA works?
I think the main takeaway is really seeing how AI, using these sophisticated language models and these specialized tools like we discussed, can automate really important initial steps in a complex process like scientific review. It provides a much faster way to get that first overview of a document and some initial comparative data points, which ultimately can lead to more efficient and hopefully better informed evaluations down the line.
So it mirrors that desire we all have to just get to the core of complex information faster.
Exactly. It's an example of AI assisting with that.
And was there anything that maybe surprised you or stood out about how this agent actually performed when it went out to try and find information online?
Yeah, I think what really stands out is how clearly it demonstrates the real-world challenges, the difficulty of extracting very specific data from the vast and varied landscape of online scientific publications.
And messiness, you mentioned.
The messiness, exactly. Despite its sophisticated design, despite having multiple strategies for finding PDFs or getting text from web pages,
Yeah.
the agent frequently ran into obstacles. It wasn't able to consistently extract those target metrics across the board.
Right.
And I think this really illustrates for you, for anyone listening, that while AI is incredibly powerful, it's not. It's not a magic bullet.
Still has limitations.
Definitely. And the inconsistent way information is presented online, different formats, different phrasings, that can be a significant hurdle even for advanced tools like this one.
That's a really important point to keep in mind. It's a powerful assistant, but it's still dealing with the messy reality of the internet and scientific publishing.
Precisely.
Okay, thinking more broadly now, beyond just the world of peer review, what are some other areas where a tool like this, something that can process documents and compare specific data points across them, could be really valuable?
The potential applications are pretty extensive, I think.
Like what?
Well, imagine using a similar kind of agent in the business world for, say, competitor analysis.
Ah, yeah.
You could quickly compare key financial metrics, maybe market share data across different company reports or press releases.
Okay, that makes sense. Anywhere else?
Maybe in policy research, you could use it to compare specific statistics or outcomes across various government documents or reports from different regions.
Right, tracking specific numbers across different reports.
Yeah. Or even on a more personal level, maybe. If you're researching, I don't know, the effectiveness of different treatments for a particular health condition by looking at multiple studies. This kind of automated extraction and comparison of key results, key numbers, could be incredibly useful for just quickly getting a handle on the main data points.
So it's really about accelerating that process of finding and comparing specific pieces of information across a whole bunch of different sources, which, let's face it, is a pretty universal need in this world overflowing with data.
It really is. It tackles a common bottleneck.
Okay, so to wrap up our deep dive today, here's maybe a final thought for you, our listeners, to consider. As AI tools like this reviewer assistant agent become more and more capable and are more integrated into various parts of our lives, how might they fundamentally change the way you approach learning about and evaluating information in your own fields of interest or just generally?
Yeah, that's a great question.
What do you think is the right balance between the speed and the efficiency you get from automated analysis like this, and the critical thinking, the nuanced judgment, the context that really only you as a human can bring to the table.
Finding that balance is key.
It's definitely something to think about as these tools become more common.